So before we get started, there's two things I'd like to mention. The first is that all the slides, speakers, notes, and the demos are available for download, and I'm going to be providing a link at the end of the talk. I tend to be one of those folks who can't keep up with the speaker and take notes at the same time, so for those folks in the same situation, there is no need to take notes. Everything I'm covering is going to be available for download, absolutely everything. It's not normally an applause line, but thank you. The second is to please hold all questions until the end. If you've got questions, please make a note of them and ask me afterwards. With luck, I'll be able to answer most of your questions during the talk itself. So OS X has a layered security model, and it's based on the idea that one layer failing should not defeat all safeguards. So by relying on multiple layers of protection, OS X security model aims to reduce the opportunities for an attacker and also blunt or delay any attacks that get launched. So Gatekeeper is one of the outer lines of defense. It allows users to restrict which sources they can install applications from, with the general idea being that malware is not going to be coming from one of your allowed sources. Now, the way it does this is by checking to see if the application is digitally signed and by who. So there are three ways that Gatekeeper can be set to allow applications. The first is Mac App Store. So this allows only applications downloaded from the Mac App Store to be launched. Gatekeeper in this case is checking for the certificate used by App Store apps and is only allowing those applications. Second, App Store and identified developers. And this allows applications downloaded from the App Store or those applications signed by certified developers to be launched and used on your Mac. So this is the default setting in 10.8 and later, and it allows developers to distribute apps outside the App Store. Here, Gatekeeper is checking for the certificate used by the App Store or the Apple Developer ID certificates used by certified developers. So the last way you can set Gatekeeper is to Anywhere, which allows all applications to be launched. So this means that Gatekeeper is effectively off. It's not checking certificates, and anything downloaded can be launched or otherwise accessed. However, the OS does still notify you that you downloaded this and where you got it from. Well, why? Well, another layer to the defenses is showing in this dialog box, which is file quarantine. Now, this was first introduced back in 10.5 as a way to provide at least some protection against malware by informing users of what they were downloading and from where. Now, with Gatekeeper off, file quarantine's notifications are mostly informational and they don't really block anything. So Apple has built on the foundations of file quarantine to create XProtect, which is Apple's built-in malware detection system. XProtect checks application file signatures rather than certificates, so it's able to work with Gatekeeper to detect malware disguised inside of applications and prevent their launch. So Apple considers Gatekeeper's role as being so important that as of Yosemite and later, disabling Gatekeeper does not mean that it is permanently off. After a set amount of time, which is currently 30 days, the OS function shown will re-enable Gatekeeper with the Mac App Store and identified developer setting. So for those interested, there's more information on that available via the link on the screen. OS X also uses sandboxing extensively. So a sandbox typically provides a tightly controlled set of resources for programs to run it. Network access, the ability to inspect the host system, or read from input devices are usually disallowed or heavily restricted. So the nice way to think of it is that your apps have their own little box to run in, and they can't interfere with each other. However, this is probably a more accurate way of depicting it. The app is in its own jail, and it only gets access to whatever resources the OS allows through to that jail. So the next layer of defenses is the Unix permissions model that OS X uses, which governs which users and groups can access which files and which directories. So if a particular user account requests access to a particular file and directory and does not have the necessary rights, that account is refused access. And the innermost layer of defense are keychains. Keychains are very specialized databases which are designed for the storing of secrets. So passwords, private keys, PIN numbers, these are the kinds of secrets that Keychain is designed to store securely. To help protect these secrets, keychains are encrypted. And this cryptographic protection is why that if you don't know the password to a keychain, you're not getting into it. So that's a security model as of Yosemite. Looks okay, right? Well, there's a long-standing issue with the defense model, and it's been there for decades. It lies in the POSIX Permissions layer, and it pre-exists OS X. It even pre-exists Apple as a company. Root is the super user for a Unix system. It can do anything, And getting root privileges on a system via privilege escalation is the goal for most malware. So Unix is designed to let the root account have access to everything. When asking what root can do on a system, it may be better to ask what root cannot do, because that list is very, very short. If you want to completely compromise a system, getting root access is a reliable path to success. So Apple has not ignored this issue, and they put some controls in place to limit the actual root user. Now, these controls include disabling the root account, discouraging its use, and providing other ways to access elevated or root privileges using other means. However, this root account is still present, and it can still do anything on the system. So to limit what the super user can do and add yet another layer to Apple's security model, Apple has developed System Integrity Protection, or SIP, for OS X El Capitan. SIP is designed to limit the power of root and protect the system even from its own super user. So as part of this new security model, the OS X kernel has SIP-related functionality built in to prevent processes from writing to certain protected parts of the file system. And SIP's configuration is stored in NVRAM, so the current configuration will apply even if boot drives are switched and also if the OS is reinstalled. So SIP is an overall security policy with the goal of preventing system files and processes from being modified by third parties. And to achieve this, it has the following concepts: file system protection, runtime protection, and kernel extension protection. So to take a look first at the file system protections, Apple has set a number of directories used by OS X as being protected by SIP. Now, with some exceptions, which I'll be talking a little bit more about in a bit, all files and folders contained within those directories cannot be moved, edited, or changed by root or any other user on the system. So Apple has also set a number of directories used by OS X as being explicitly available to developers. In one of the exceptions I was just talking about, /user is protected by SIP, but user local is not. So that means that developers are explicitly permitted to place files and folders inside of user local without worrying that Apple will lock down that directory. So SIP's protections are not limited to protecting the system from file system changes. So there's also system calls which are now restricted in their functionality. For example, dtrace can inspect system processes using either the instruments application or the dtrace command line tool. However, this does not block inspection by the developer of their own applications while they're developing them. Xcode's tools will continue to allow applications to be inspected and debugged during the development process. And for more information on this, I recommend taking a look at Apple's developer documentation for SIP, which is available via the link on the screen. So SIP also blocks installation of unsigned kernel extensions. So in order to install a kernel extension with SIP enabled, a kernel extension must be signed with the developer ID for signing KEX certificate and also be installed into library extensions. So more information on this is available in Apple's developer documentation for SIP. And for those interested, the kernel extension documentation is available via the link on the screen. So SIP has a configuration file, which is available in System Library Sandbox and is named rootlist.conf. Now it lists all the applications and top-level directories which SIP is protecting. So this is a list that's kind of hard to read all at once, so I'm going to break it down into what's protected in applications and what's being protected outside of applications. So SIP is protecting the core apps which OS X installs into applications and applications utilities. Now this means that it will be no longer possible to delete the applications which OS X installs, even from the command line when using root privileges. And to be honest, I wish I'd had this probably about a year ago when I got in a laptop where the only thing left in the applications was just self-service. And that was because Casper had reinstalled it. So SIP is also protecting a number of directories and symlinks outside of applications, and the top levels of those directories are listed in rootlist.conf. However, if you notice, some listings have an asterisk in front of the directory. So Apple has defined some exceptions to SIP's protection in the rootlist.conf file, and those exceptions are marked with asterisks. So two important ones for Mac admins are the exceptions made for the user template folders and user libexec cups, which is where OS X stores printer config information. So this is in addition to the exception for user local that I'd previously mentioned. So there's also some interesting mixing of protection modes visible in this configuration file. For example, there's an asterisk in front of system library extensions, which means that that directory has an exception from being protected by SIP. However, the very next line has an asterisk following system library extensions, which in this case is a wildcard for everything inside the directory. So system library extensions as a directory has a SIP exception, but everything inside that directory is explicitly protected by SIP. So when I spoke with Apple engineers about how this configuration file was updated and if we could add our own exceptions to it, it was made clear that Apple considers this file theirs, and that any third party's changes to it would be overwritten by Apple. Now, updates to this configuration file are coming via software update, similar to how Apple has been updating gatekeepers and XProtect's configuration files. Now, to see which files have been protected by SIP, use the ls command with --O. SIP protected files will be labeled as restricted. So for example, here's the SIP protected directories and symlinks available at the root level of the boot drive. Now, one important thing to know is that even if a symlink is protected by SIP, that does not necessarily mean that the directory they're linking to is being protected by SIP. So at the root level, there are several SIP protected symlinks pointing to directories stored inside the root level directory named private. However, if we look inside that directory named private, the directories which those symlinks point to are not protected by SIP, and both they and their contents can be moved, edited, or changed by processes using root privileges. So in addition to the list of SIP exceptions which Apple has set in rootlist.conf, there's in fact a second list of SIP exceptions. Now this list includes a number of directories and application names for third-party products, including the location of the Jamf and Jamf agent binaries in user SBIN. So for those folks who were testing El Capitan before Casper 9.8 came out and you're like, Casper's working fine in user SBIN, what's going on? Well, Apple had set this exclusion for it. So like rootlist.conf, this exclusion list is Apple's, and any third party's changes to it will be overwritten by Apple. And if you want to see the current list, it's available via the link on the screen. So SIP can be managed to the extent of turning it on, turning it off, adding and removing IP addresses into a NetBoot whitelist, and reporting on whether or not SIP is enabled or disabled. So the tool used to do this is userbin csrutil. Now when you run csrutil without any associated commands, it will pull up this help page. So csrutil is able to work with SIP because it has a unique application entitlement assigned to it by Apple. And this entitlement is viewable using the code sign command shown on the screen. Now to help ensure that SIP cannot be turned off or otherwise affected by malware or other attacks, it can only be disabled while booted into the recovery environment, so like Recovery HD or Internet Recovery. So when booted from recovery, the command used to enable SIP is csrutil enable. And let's take a look at how this works. So the first thing I'm going to do is I'm going to run csrutil status, and it's telling me that SIP is disabled. So let's go ahead and run csrutil enable and hit return. We've successfully turned on SIP, and now we need to restart. Anytime you make a change to SIP, you are going to need to restart in between, but since you're having to boot to recovery anyway in order to make these changes, it's kind of a built-in part of the process. All right, so let's go ahead and log in. Go into terminal. And now if we run csrutil status, it'll tell us that SIP is now enabled. So when booted from recovery, the command used to turn SIP off is csrutil disable. The bless command in El Capitan is restricted by SIP, and this affects bless's ability to set max to boot from NetBoot sets. Now when booted from recovery, you can whitelist NetBoot server IPs as being approved for use by the bless command. So to do this, you would use csrutil NetBoot add, followed by an IP address of the NetBoot server you want to whitelist. So let's take a look at how this works. So first thing, let's make sure we don't already have any IPs whitelisted. So we run csrutil NetBoot list. It says I can't find any. So now let's go ahead and add a couple of IPs. So run csrutil NetBoot add, put in our first IP. All right, let's go ahead and add our second one. So let's run csrutil NetBoot add and put in our second IP. All right, and let's just make sure that those got added properly. So let's go ahead and run csrutil NetBoot list again. Okay, should be good to go. So let's go ahead and restart. go ahead and log in. And if we go into terminal, run csrutil status. It'll show that SIP's enabled, but now we have 2 new allowed NetBoot sources. So when booted from recovery, you can also remove NetBoot servers from the whitelist. And to do this, use csrutil netboot removed, followed by the IP address that you want to remove from the whitelist. So to see which NetBoot servers have been added to the whitelist, as we've seen in the previous examples, you can run csrutil netboot list. And another command that you have available is csrutil clear. And what this does is it resets SIP and it'll clear the NetBoot whitelist. Effectively, what this is doing is it's taking SIP back to the factory defaults. So after a reboot, SIP is enabled if it was not previously, and running csrutil netboot list will show that no NetBoot IPs are listed. So let's go ahead and take a look at how this works. Let's go ahead and run csrutil status. Shows us that SIP is disabled, and I've got a couple of allowed NetBoot sources. So next, let's go ahead and run csrutil clear. All right, successfully cleared, which means we're back to the factory defaults. Now let's go ahead and restart the machine. Okay, let's go ahead and log in. All right, let's go back into terminal and let's see what we got. So now if we run csrutil status, remember it was disabled before, it's enabled now, and let's just confirm that we don't have any IPs in that NetBoot whitelist. So I'm going to run csrutil netboot list. Sure enough, they've all been cleared out. So if you try to run the csrutil enable and disable commands while booted from a regular boot drive, you'll receive a message that these commands need to be run from recovery. So the current SIP configuration will remain unchanged in this case. Likewise, if you try to run the csrutil netboot add and remove commands while booted from a regular boot drive, you'll receive a message that csrutil was unable to change the configuration and the status of netboot will remain unchanged. So what can you run with csrutil when you're booted from a regular boot drive? Well, you can run csrutil's reporting functions. For example, to learn if SIP is enabled or disabled, you would run csrutil status, and that command can be run without root privileges, and it'll tell you if SIP is on or off. Likewise, you can run csrutil netboot list, and it'll report on which IPs have been set as allowed netboot sources when using the bless command. So if SIP is off, and you run csrutil status while booted from a regular boot drive, you may receive a confusing message indicates that SIP is enabled, followed by a list of individual SIP functions which are disabled. Well, if all functions are showing as disabled, SIP is actually completely disabled. This is just kind of a confusing message. Because it's confusing, I filed a bug report on this. So for those who wish to duplicate it, I've posted my bug report to the link shown on the screen. So one other thing to know about SIP and recovery is that there are 2 environments where SIP's protections are disabled. So one is the OS X installer environment, which is how Apple will be able to upgrade a SIP-protected Mac in the future. And the other one is the recovery environment. In fact, the 2 are actually the same environment, they just have different names. The main difference between the OS X installer and recovery environments is that recovery doesn't have a locally stored cache of OS X installer files. Other than that, they're completely identical. So the other place where SIP's protections will be disabled is in specific circumstances where installer is installing software. So those special circumstances are when Apple has signed the installer packages certificate with Apple's own certificate. Developer ID signed packages will not be able to alter SIP-protected files or directories. Okay, so at this point we've discussed a number of things, most of which ended in can only be changed in the recovery environment. So where does this leave us as Mac admins? So let's tackle NetBoot first. SIP affects the bless command's ability to set alternate boot disks, including the ability to set a NetBoot set as a startup drive. So the first question to answer is, do you use bless to set your Macs to NetBoot? If the answer is yes, you'll need to whitelist. But if the answer is no, you don't need to whitelist. So why is this? Well, the root of the issue is that SIP now restricts the bless command's ability to write to NVRAM. Meanwhile, the bless command must write to NVRAM as part of setting a Mac to boot to a NetBoot set. So to address this, Apple added the NetBoot whitelist to SIP as a way to define which IPs bless can write to NVRAM without otherwise compromising SIP's protection. So how can you tell if you don't need to use bless? Well, you open Startup Disk and System Preferences, and you see if your NetBoot set appears there. If you can see it, that means you have a NetBoot server on your local subnet, or helper IPs have been set up to allow your Mac to boot to a NetBoot server that's located outside of your local subnet. So if your NetBoot sets, or sets, are visible in Startup Disk, SIP won't affect your ability to NetBoot. You can use Startup Disk to select a NetBoot set. You can hold down the N key at startup. You can hold down the Option key at startup, and you can select your NetBoot set that way, just like you've always been doing. So the main exception would be if you're using the bless command in a script or other means to automate NetBooting from a particular NetBoot set. Now in that case, despite the fact that your NetBoot set is available in Startup Disk, you'll still need to whitelist your NetBoot server using CSRUtil because bless is in the mix. So I mentioned helper IPs on the previous slides, but not everyone may be familiar with these. So these are settings in your configuration of your network equipment. So you'll need the assistance of your network folks to get these set up. So most folks have their network subdivided into VLANs these days, so you'll need to have helper IPs set up on the various VLANs where you want to have NetBoot available. So how helper IPs work is that they relay all DHCP packets to the specified IP address, which will be the IP of your NetBoot server. Now this DHCP relay doesn't break anything, it just makes sure that your NetBoot server is able to hear the broadcast DHCP request which your Mac is sending out when your Mac wants to NetBoot. So Parallels has a pretty good write-up on how this works, which is available via the link on the screen. And I'll also be providing links to more information at the end for those folks who want more information on helper IPs. So if you're using bless, as I mentioned, you will need to use CSRUtil while booted into recovery to whitelist the IPs of your NetBoot servers. Now Apple has also provided a way to set the whitelist when you're using System Image Utility to build a net install or net restore set. So this option is an automator action called Bless NetBoot Server, and it's made available when you click the Customize button in System Image Utility. So to have your NetBoot IPs whitelisted, enter the relevant IPs into the Bless NetBoot Server entry blanks. And once you've added the IPs into the workflow and you've built your boot set, your NetBoot Server IPs will be automatically added to the SIP whitelist on machines set up by the relevant net install or net restore set. So is there any special magic here in this Bless NetBoot Server automator action? Not really. You could replicate what it does using a script similar to what's currently showing on the screen. The crucial detail is you need to run that script while you're booted into recovery. And the Bless NetBoot Server automator action helps make that happen for Apple's net install and net restore sets. So Bless also has the ability to set a Mac to broadcast for an available server, which is described on the Bless man page. So let's take a look at how this works with the SIP NetBoot list. So we're going to go ahead and run CSRUtil, NetBoot add, and the IP address to use is 255.255.255.255. And I've gone ahead and added that. Let's make sure it got added properly. So we'll go ahead and run CSRUtil NetBoot list, and it got added. All right. So let's restart and see what we got. All right, let's go ahead and log in. And go into terminal. Okay, so first things first, let's make sure that NetBoot whitelist is showing up properly. So we'll run CSRUtil NetBoot status. It's an allowed NetBoot source, so let's go ahead and run it exactly as shown on the Bless man page. So sudo bless NetBoot server BSDP, and then that IP address. All right, since we're using sudo, let's go ahead and put in our password. And unfortunately, no, you're not going to be able to use this method. So if you are using Bless in any way, shape, or form, you're not going to be able to set your Mac to just listen for your NetBoot server and have it pick up. You're going to need to whitelist your specific NetBoot servers. So another issue has to do with imaging. So SIP is making parts of the OS read-only. So how does that affect wiping the hard drive and imaging the machine? So let's take a look using Apple's NetRestore. So in this case, I'm going to wipe the boot drive and lay down just the OS in one account named administrator. And just to show you I don't have anything up my sleeves, I'm just going to go ahead and run CSR util status, and sure enough, it's enabled. All right, so let's go ahead and restart. We're going to NetBoot to that NetRestore set. Okay, so we're booted. Go ahead and get the process rolling. Select our disk. Have put down that fresh image, put down the recovery partition. All right, everything looks good. It's going to restart. Okay, and here we are, freshly imaged machine, administrator account showing at the login window. What effect did SIP have on this? None, zero, zilch. You can reimage, there's no problem. You can image just like you always have. So as just mentioned earlier, SIP's protections will be disabled in specific circumstances where installer is installing software. Now those special circumstances are when Apple assigned the installer package certificate with Apple's own certificate. So if you don't have access to Apple's certificate, installer will not be able to install to SIP protected locations. So as an example of this, here we have an installer that someone's building in Composer, which is designed to install a very important text file into system. Must go into system, can't possibly go anywhere else, must go there. So that person has handed off their installer to us, so let's go ahead and run it. All right, so it's very nice that they label it very clearly. Let's go ahead, hit continue. All right, yeah, that's the boot drive, that's all fine. Hit continue, hit install. I'm an admin, yeah, I'm gonna put in my password, I can do this. Ooh, this package is incompatible with this version of OS X, may fail to install. I don't read error messages. Install anyway. Failed? Man. All right, so when we go and take a look into the logs and see why it failed, we'll see these two messages logged. One's a warning saying that SIP's on and that the package will fail to install. And the other one is an error message saying that the package contains system content and that installer is expecting it to fail. So installer is aware of SIP, it knows what's going on, and it does try to warn you if the installer that you've got is probably going to fail because it's trying to install something into a SIP protected location. And that's that dialog box that popped up. Installer does give you the chance to just go ahead and just bull on through anyway, because it's all about choices. But yeah, it's, when you see that kind of thing, you know, just take a look and be like, maybe I shouldn't install this. So to go along with installing items, Apple made a SIP exception, which I previously mentioned, which is likely important to a number of Mac admins in this room. And that exception is for the user template directories located in /system. So for admins who have used the fill user template option in Casper, this exception means you'll continue to have this option available to you. Now another concern is how SIP will affect the functionality of software used on your Macs. So software from the Mac App Store, that's going to be fine. Apple's been defining installation requirements for a while to make them work with SIP. Vendors who have been following Apple's guidance for at least the past few years on moving away from deprecated methods, they will likewise be fine. However, a lot of environments have to deal with older software or new software written by vendors who, shall we say, haven't updated certain components in years. So I'm sure everyone has a vendor who's still using unsigned kernel extensions. Only stopped using startup items when Yosemite made them just flat not work anymore, or other functions which Apple has deprecated. So a number of vendors who fall into this category also posted support articles showing how to turn off Gatekeeper as part of the installation process for their software, since they also weren't signing their installers. So from the next slide, I'm gonna get up on my soapbox a bit, so I want to give everyone a little fair warning in advance. I anticipate similar support articles appearing. In fact, I've already started seeing them to appear, showing how to turn off SIP prior to installing said software product. And in my opinion, vendors who provide advice to turn off SIP on your Mac are providing a clear and unmistakable signal that they don't want your business. They're asking you to They're asking you to reopen the hole in your Mac security model that SIP is designed to close, and they're also asking you to assume additional risk in your own environment because they don't want to invest the time and resources needed to update their software. Demand better from those vendors, or leave them. So I'm climbing off the soapbox now. So if you've got older software that just can't be updated for SIP compatibility because it is abandonware or because the in-house person who wrote it has now retired and they're off sailing the world, that's kind of a different problem. In that case, I would still not recommend disabling SIP on your own machine. What I would recommend is maybe taking this into a virtual machine or even just dedicating like an older machine somewhere in your environment and have that older machine dedicated to running this particular software package. So as an example of software that's been updated for SIP compatibility, Casper's own Jamf binary has moved from user sbin to user local bin on Macs running Lion and later. However, one thing to be aware of is that the Jamf binary is not moving from user sbin for Macs running 10.6 and earlier. And folks supporting environments that include both 10.6 and earlier as well as 10.7 and later may want to include logic in their script that can identify the location of the Jamf binary. And here's an example of how you could do this. This is taken from a script that I wrote. And to see it in context, please use the link at the bottom of the screen. And as a side note, for those folks who looked at the previous slide and said, that's not quite right for the new location of the Jamf binary, you are 100% correct. So the Jamf and Jamf agent binaries are not actually in user local bin. They are in user local Jamf bin. So Jamf added symlinks in user local bin that point to the actual location of the binaries. The reason why the symlinks are there in user local bin has to do with path environment variables. It's not something I want to really get into now. If you're really interested, I'll talk to you afterwards. And my assumption for why Jamf decided to take the approach of using symlinks is that I think they took it just in case they ever had to move these binaries again. But that's just my assumption and speculation. So another example is how SIP affects browser plugins. So SIP's protections of /system affects XProtect's configuration files because they're stored inside /system. So as the XProtect configuration files are locked against editing, this means that they can no longer be managed to allow older versions of the Flash and Java browser plugins to run. So if your shop includes a mission-critical system that requires using older Flash or Java browser plugins, I recommend working with your vendor or your in-house developers to find out if the use of those browser plugins can be discontinued. In the more likely scenario, if their use can't be discontinued, see if the system in question can be updated to support the latest versions of those plugins and continue to be compatible as new versions of those plugins come out. So if updating the system is not an option, there is a way to allow older plugins to access specific sites. So by adding the needed sites to a whitelist in Safari and setting those specific sites to allow always, those sites can use the older browser plugin even if XProtect would otherwise block the use of that plugin. Websites not included in that whitelist would still have the use of the older plugin blocked. So another thing to know is that because SIP writes to NVRAM, resetting NVRAM back to factory defaults will also reset SIP back to factory defaults. So in this case, it's like running CSR util clear. SIP will be enabled. Any entries in the NetBoot whitelist are gone. They're wiped out. So in my testing, I verified that a param zap does this. So since a param zap clears NVRAM, performing a param zap will reset SIP back to its factory defaults. So for folks who need to maintain NetBoot whitelist, I really do recommend you talk to your colleagues about this and get some IT education going. Otherwise, you may just have, why is this machine not netbooting anymore? Oh, NetBoot whitelist got wiped out. So it is also possible to enable SIP protections and selectively disable aspects of it by adding one or more flags to the CSR util enable command. So all require being booted from recovery in order to set these. So for example, here's the command to enable SIP and allow installation of unsigned kernel extensions. The other options include enabling SIP while disabling the file system protections. Here's the command to enable SIP and disable the dtrace restrictions. Here's a command to enable SIP and disable the debug restrictions. Last but not least, here's how to enable SIP and disable your restrictions on writing to NVRAM. And you can mix and match these. So when you run CSRUtil status, you should see that the other protections are listed as enabled, while the specific protection you indicated is now disabled. Now, another interesting part of Apple's developer documentation for SIP is this note, this kind of vague, not really terribly helpful note, indicating that it's possible to configure SIP for environments that can't access recovery. So I asked Apple about this. And when I followed up with Apple about this, Apple Enterprise Support told me that this meant I could configure it using NetBoot, using a NetBoot set that included the needed recovery environment. So the example they used was leveraging a new option in System Image Utility to create a package-only installation NetBoot set. And this is designed to install only scripts, configuration profiles, or packages, and not install an OS. So to test this, I built a script that uses CSRUtil to add 2 IP addresses to the NetBoot whitelist. So once I had my script written, I built a package-only NetBoot set using System Image Utility, and I added my script to it. And this is the only thing that's in this NetBoot set. So let's take a look at how this works. So first of all, I'm going to run CSRUtil status. It's showing me that SIP's enabled. And let's go ahead and run CSRUtil NetBoot list, and it doesn't find anything in the NetBoot whitelist. So let's go ahead and restart. All right, at this point, I'm booting off of that package-only NetBoot set, which is by itself an interesting topic. I highly encourage you to look into this because it's really interesting, because it just, it's something Apple's never done before, which is essentially helping you to just configure an OS without, reinstalling it. So we're going to go ahead and get that process rolling, and it's pretty quick. It's just running one script. All right, so it's all done. I'm going to restart in a few seconds. Okay, so let's go ahead and log in now that we're back to our regular boot drive. Let's go into terminal. Let's go ahead and run CSRUtil status. All right, so SIP's still enabled, but now I have those allowed NetBoot sources set there. So SIP is a big change, but I also think it should be considered a work in progress. So I'm expecting to see additional changes to SIP's functionality, both in El Capitan and in future releases of OS X, as Apple sees how SIP works in the real world. So because you can never have too much information about this brand new thing that you just learned about, I've got some useful links here. To go back to my thing about helper IPs and NetBoot, I've got some links here talking about NetBoot, SIP, how NetBoot works with SIP, and also how you can set up helper IPs of your own. And possibly the most important link you see in this entire presentation, this is how you get it all. So PDF is available from the top link. It has the slides and speakers notes. Keynote slides are available from the bottom link. That's how you get everything. You get the demos, you get what I've been talking about, you get the slides, absolutely everything. So I'm going to leave that up on the screen, and I think I'm going to open the floor for questions. Not sure if Tom comes back out at this point, or, oh yeah, there he is. All right, first customer.
My question involves Casper Remote and whether or not you can still select a NetBoot option using it since that feature is left in it.
Okay, so that question was.
We should, yeah, okay,
Okay, So the question was using Casper Remote and being able to set a NetBoot set with Casper Remote, since you believe that uses the bless command. As far as I'm aware, you are correct. That does use the bless command. So in that case, you would need to whitelist that NetBoot server IP. Interestingly enough, if you use Apple Remote Desktop and you use the set startup disk functionality in Apple Remote Desktop where you're not using bless, that does work, because that's actually using the startup disk framework on the remote machine. So that works where Casper Remote may not. Questions? Oh, got somebody waving over here. So the question is, system library extensions, can you drop something in there? The answer is yes. You can put something into system library extensions because it is not being explicitly protected by SIP. In fact, it has an explicit SIP exception. I'm not sure why Apple set it up the way they did, where they said the directory itself is not protected, but everything inside the directory is protected. I'm sure it has something to do with something they ran into in testing, and this was their way of fixing it. But yes, you can do that. You can drop it in. However, if you drop something into system library extensions and it's unsigned, don't expect it to run, because SIP is basically must have that kernel extension be signed, and it must be in library extensions in order for OS X to pick it up and run with it. Yes, that's another fun bit. It's now trapped in Amber, and you can't take it back out. Until you go into turn off SIP or go into recovery and delete it out that way. Yeah, so that's kind of interesting that way. Yes. Sir. That's a good question. So the question was, can the packages only NetBoot be run without user interaction? The answer is, I don't know. I basically just tested it out, but I didn't set it. Yes, you can, because you can set it for the target hard drive. So if all your hard drives are consistently named one thing, that should allow you to automate that. But if someone changes the name of the hard drive, it won't work anymore. So I just had mine set up to manually select. You in the back. You have identified a fun chicken and egg problem, which is that if you don't have, and this is something that I've raised with Apple as a response to here's our solution. I said, so what if you can't write to the whitelist to tell it to NetBoot? They said they're opening a separate case on that. They asked me to gather some impact data. So you're absolutely right. So if you can't NetBoot, because you need to add something to the whitelist, that also means you can't NetBoot to add to the whitelist. So in that case, you do have that chicken and egg problem, and Apple apparently not considered that. So talk with your own, if you need that capability, talk with your own Apple SEs, talk with Apple Enterprise Support, and see if you can find an answer for it. Because as of today, they haven't got back to me to say, and here's how we solve that. Sir.
Has not said anything about use case where you completely upgrade the OS of the machine and how SIP can fly. I asked because recently came across a case where the 10.7 era kept not detected by SIP, but was still running on the machine and OS.
Okay. So the question was, how does SIP handle OS upgrades where it may be leaving some things behind? And there's a couple of answers for this. One, Apple is supposed to move things out of system locations as part of the OS installation process. That usually ends up in a library quarantine system migration. I don't remember the exact path. However, if the referenced kernel extension is in that third-party SIP exception list, SIP may leave that alone, or rather the OS X installer process may leave that alone. And so I would encourage you to take a look at that third-party SIP exception list that I have linked as part of my presentation, and take a look to see if something that you have is affected by this. because that may help explain why this particular kernel extension, this particular application, why it stayed in place when you would think otherwise that the El Capitan upgrade process would have just moved it out of the way. Questions? Oh, over there. Yes, you, sir.
Just in your humble opinion, is this Apple being like super proactive about their security structure, or do you, like, historically we haven't seen a ton of malware and adware in our organizations, but historically have malware writers been using these directories to store those files, or is it Apple more just kind of covering themselves?
So this is going to be entirely my opinion. My opinions do not reflect the standpoints of my employer, Apple, my mother, or anybody else. I think this is a combination of how Apple has seen malware writers working on the platform and also getting ahead of the curve. So this is definitely about malware protection. It's about helping to get ahead. It's about making sure that those, once again, going back to that idea of the multi-layered defense, this is about blocking those attacks. That's about blunting those attacks. That's about slowing down those attacks. So that's what I think this is about. Yes, you, sir. That's a good question. I don't know. The short answer is really going to be I don't know. This, like I said, SIP. So to repeat the question, because I haven't previously, the question was, do I think that Apple is going to prevent us from turning parts of SIP off in the future? Because currently we can turn it all off. We can selectively disable stuff. Do we think that Apple's going to block us from doing that in the future? For this, I'm going to go back to a vast and wise source of knowledge, Yoda, and say, always in motion is the future. I don't know. It could be. This is part of SIP being a work in progress. It could be Apple locks us out of stuff. It could be that Apple just continues on as they are. What I've seen from Apple over the past few years has been that they always, for every lockdown that they do provide a way for those folks who need to disable it. They do provide a way to disable it. Like, for example, Gatekeeper rearming after 30 days. Gatekeeper flips back on. They have a switch in there that says you can turn this, you can permanently disable that. They didn't have to put that in. I think CSR Util is going to have comparable functionality, but I simply don't know. I hope it does. Oh, yes. Hard to see in the lights.
So, first of all, great presentation. Thanks for actually showing somebody using system of utility. So it's my understanding that if you're running El Cap and you have another drive connected to a standard El Cap, it respects SIP on that other system.
Yes.
So my question is, imaging workflows that replace the drive but block copy work. Imaging workflows that then try to do something after that may fail. Are there any, and I'm thinking about beyond Jamf, like deploy studio runtimes and things like that. Have you done any experimentation with that?
So the question was basically, you have other drives that are,
Because when you're imaging,
right.
If your imaging runtime is running El Cap,
Right.
and you're imaging another drive,
Right.
and that drive has system integrity protection turned on, you can't write to certain directories that you would otherwise be able to.
Yes. So essentially, if you're booted from another drive and you're trying to write to another drive and SIP is enabled, will you be able to make those changes needed on that other drive? And the answer is maybe. And the maybe comes in if your boot set is running the recovery environment or running at least enough of the recovery environment that SIP is showing up as disabled. Because, I mean, it's not actually disabled. It's basically just I'm running in the recovery environment, so I'm just going to let you do what you need to do. So I would say that the answer there is going to be whether or not your NetBoot set, whether or not your imaging solution is running that recovery environment. So for Apple's Net Installer Net Restore, sets, that answer is yes, because they are running the recovery environment. They can change those things because they're running the recovery environment. If you're running, say, a NetBoot solution that relies on a full OS, like a regular boot OS, like a regular NetBoot set, and here's where like Casper imaging, or auto Casper NBI, anything that's not running that recovery environment, you may hit some issues. But for those who base themselves off of recovery, like I believe Deploy Studio does, like I believe, trying to think what other imaging solutions there are out there. I think Imager, the open source solution, I believe those are using the recovery environment as well. So basically, if you're able to tap into the recovery environment as part of your imaging solution, you shouldn't have issues. If you're not, you may. Sir.
Follow up on that. If you're using, for instance, target mode as a imaging process or workflow, and those directories that are being restricted aren't legitimately those directories anymore. They're actually mounted under volumes, let's say. And so does that mean that they would be open? Because they're not technically system. They're not technically.
That's, I believe they would still fall under XProtect. And it also depends, are you doing a block level copy, or are you doing, because block level copy won't be affected. Are you doing a file level copy where you're swapping files around? Yeah, that will be affected. But if you're doing that block level copy, no, that's, you should be fine. Am I speaking from experience or am I guessing? I'm speaking from the experience of working with net install and net restore, and I'm going to leave it at that.
From what I understand, El Cap recognizes other volumes that are not the system volume as another El Cap volume with SIP in it. The metadata. Yeah. It looks at the flags and goes, no, you can't write to that other drive. No, that's not my system drive. And they actually, if somebody boots off another OS to try to circumvent the bill of protections, if it's El Cap, it's still respected.
And I'm going to defer to Kevin White on this because he literally wrote the book. Yes, sir.
Rich, could you speak a little bit about those two whitelists, that comp file and the second one? Is there anything that you left out of the presentation that we should be looking at?
You mean, are there even more whitelists that I don't know about? Okay, so the question is there anything that, that I did not cover with regards to those whitelists that I discussed? Or not whitelists, but basically the configuration files. So first is the configuration file, the other one's the third-party kind of whitelisted thing. What you have is my information about it. So if there is more information, I'm excited to learn about it, but what I have is basically what went into this presentation. Any more questions? Ma'am. Oh, Adobe and catch up quickly. So my experience has been in my own shop when preparing. I'm fairly lucky that I don't have to worry about too many software vendors that aren't following the blessings of what Apple's telling us to do. The best thing I can do for those vendors that just are playing catch up, or sometimes will just never catch up, is apply pressure. You're the customer, you give them money. And there may be some cases where the vendor just won't. And in that case, the best thing I can do is recommend, finding a way to virtualize that, to have it run on Yosemite, or even, just have a dedicated machine set aside that can run Yosemite potentially forever. Because that's a tough question. I would not recommend turning off SIP. But I'm going to leave that as a judgment for, each environment. In my own environment, I'm going to be leaving it on. I don't anticipate problems. But I know that some vendors are just going to be like, our software is perfectly fine. You just need to turn this off and everything will be great again. Sir.
Do you know if the recovery drive itself is specific?
I'm sorry, could you repeat that question?
Recovery partition itself, is that
The recovery partition, is that SIP protected? Well, SIP is disabled in the recovery partition. I mean, SIP is running, it's just that like if you run ls-O, stuff will show up as being restricted, but the protections are essentially in abeyance. They're not being enforced. And the reason why Apple set this up to run in recovery is that you can't really modify recovery. That's Apple's own, and they basically said that because this is an environment that we know and we control every part of it and we can trust it, that's why we're putting this capability there.
I just wondered if that would be a future attack vector or malware potential. That's where I'm
Yeah, it's because it is such a manual thing. Once again, this is all part of blunting and slowing. So a determined attacker with access to your machine and you haven't encrypted your machine, eventually they'll figure out some way to mess with you. It just takes physical access. And for that kind of thing, I would recommend, File Vault 2 or another, encryption solution so that you do have that data protection at rest. But in terms of, SIP, it's more about slowing and blunting and hopefully stopping. Sure thing? Yes.
Kind of follow up on that, I'll try to talk loudly. If you boot into OS X recovery, you can do anything you want to the system drive.
Yes.
Including mess with the system.
Yeah.
So, and that just goes in general. If you boot from another OS, you've already broken SIP, right? That's the whole point. You've got to prevent, if security is your goal, you need to have firmware passwords or file vault enabled so that when you boot from another OS, you can't mess with the system drive. So SIP by itself is still vulnerable from that attack.
Yeah, SIP is a layer to Apple's security model. It's not the only one, and all the various layers work together to protect the OS and protect your data. So it's not an end-all, be-all security solution by itself. Any other questions? Well, about Apple's developer documentation, I filed a couple bugs on that. I would say test that. Trust but verify.
But the caveat, though, is that if you want to use the CSR, your test command, and your target mode, you can't do that. Because you're not actually writing the NVRAM on that.
Thank you. Another question I think I saw? Do I have a list of terrible apps? I'm sure we all have our own list of terrible apps. No, I'm not going to call out any particular vendor because, for one thing, I like not being sued. For another thing, they may in fact be working on it, and like tomorrow they'll come out with an update that makes everything better. And it's one of those things where I'm like, put the pressure on your vendors, and also keep in mind the vendor may have updated. It's just maybe that your environment didn't. So, I would also say look into it, and if you find that you're in a situation where you're simply a few versions back in the software, make the case to the folks who, write the checks that you really do need this time. This is absolutely essential. This must happen. Update to the latest version of the software.
So we are past our time.
Oh, we are over our time.
Thank you, everybody, for showing up. Thank you, Rich.